Hello and welcome. Let's look at lesson 5.2. Once again, we get to work with systems of equations. That means we should be seeing two equations with two variables such as x and y. Today, our focus, as you can see, is going to be using the method of substitution. So our essential question would be, how can I solve a system using substitution method? Yesterday, as you recall, we used the graphing method and we, graphed our two lines and we're looking for that common point and naming that point and found out that that indeed was our solution. So today we're going to do things just a little bit differently and use a substitution technique. I'll just move that out of the way. So, solving a system of linear equations by substitution. You can see here that, that we will be doing a few of these steps. If you like to follow along, with written steps, there they are. It says, first off, let's solve one equation for one of the variables. So pick an equation and we're going to solve for a variable. So maybe that means we'll get it to, so it's a y equals, or maybe in fact it was easier to solve for x equals. One way or the other, we'll choose. Second, we'll substitute that expression that we gain in step one into the other equation. And then finally, we'll have to sub back to find the final variable. All right, so looking at example A here, let me thin this marker up a bit. There we go. I have y equals 2x minus 9. I'm sorry, negative 2x minus 9. And my other equation is 6x minus 5y equals negative 19. Thinking about step one, it says solve one of the equations for one of the variables. Well, what I happen to notice is the fact that this is already solved, isn't it? Look at that. Step one, equation one is already solved for the variable. So that's actually going to save us a step. So we're going to use this one and sub it into the second equation. So we'll sub into equation number 2. That was supposed to be a Q. All right, so that will look like, what will that look like? Well, let's, cancel. What I'm going to do is take and make my ink thinner. All right, that should close. 6x minus 5. And now, instead of that y, we're going to say negative 2x minus 9. Because notice in the first equation, it talks about y equaling negative 2x minus 9. So I'm going to put negative 2x minus 9 in replacement of that y. And then I know it equals negative 19. So I'm really following along with this second equation, but substituting, in fact, for that y value. Now, what we will do is let's just keep solving. So let's solve for x, and you can write that down if you want. We're going to solve, that's not how you spell solve, solve for x. So I'm going to go in blue ink. I would have 6x minus, so if I take negative 5 times negative 2x, I'll get positive 10x. And then a negative 5 times a negative 9 makes positive 45. And then on the right side, we have that equals negative 19. Accumulating like terms on the left, we can join those together very easily, just calling it 16x plus 45 equals negative 19. And now let's subtract 45 from both sides. And don't forget, I have that 16x over there on the left. 16x, these went to 0, and I get negative 64. Final step, let's solve for x, and that looks like a division step, divide by 16, and we get our answer where x is -4. Hey, we have half our solution. Woohoo! Now what we need to do is find the y value. So you'll notice step 3 says substitute that value that you found in step 2. We found x equals 16, and we'll sub it back into the original equation and solve. I'm going to go back to the equation 1 just because it looks easier than equation 2. So now step 3, we're going to take and substitute that in. So I'm going to take 6x minus 5. No, I'm not. Scratch that idea. I'm going to take y equals -2x minus 9 because it's an easier equation. And I'm going to substitute for x that -4. And look there. Now we just have 8 minus 9, or y equals -1. And we get the other partner to our coordinate pair. So our ordered pair is -4, -1. And that is the solution to that system of equations. If we had graphed it out, we would have got that same answer. Okay, I'm going to clear this board and continue on. Okay, on to the next problem, and it'll be much like the first one. Let's find step 1. What is nice about this one, though, is you will notice, once again, we have an equation that says x equals. So that makes this just a titch easier for us. So I'm going to go move from step 1 into step 2, where I take this information and I'm going to plug it in for x, right? Because it says x equals, so I can replace x with that. So we're really on to step 2 at this stage, if you're following along with those steps that were listed above. And I'm going to go 4 times, and I'm going to replace x with 6y minus 7, and then I'll continue on with plus y equals -3, using that equation there, right? All right, now it's solving, so let's solve this out. Solve for y, and that would mean let's distribute, and we'll have what, 24y minus 28 plus a y equals -3. 24 plus 1y gives us 25y. Notice they were on the same side of the equal sign, so we can just join those two pieces together, add them up. And next, let's add 28 over to the other side. I need more space, so I'm going to give myself a new column of work. And what does that tally up to? It looks like it tallies to 25y equals 25. -3 plus 28 gets us the 25. Oh, this will be nice. Divide by 25. And y turns out to be 1. Sweet, we're halfway done with our work. Now I'm going to move into step 3. If you look at step 3 up above, it says substitute that value back into one of the original equations. Well, I'm really loving equation 1, so I'm going to sub into equation 1. And I'm taking that y, I know y equals 1, and so I can go x equals 6y minus 7. But we know what y is. We solved for it. Y was 1. So we say 6 times 1 minus 7. And x would be 6 minus 7 is -1. Now we have our solution. Our solution turns out to be, there's part of it and there's part of it. And we know ordered pairs are always listed in an x, y order. There's your solution. All right, when we get to C, there's going to be more work. I don't know if some of you might need to see that. A little more work on C, because this time I don't have an equation that says x equals or y equals. So I get to choose which equation I want to solve for. And I think I'm going to take equation 1. It really wouldn't matter, either equation. I'm going to take equation 1 and solve it for y, okay? You might have said you wanted to do something different, and that is totally your choice. But I'm going to use equation 1 and go -x plus y equals 3. I'm solving for y, so I'm going to add x over. That'll give me y equals x plus 3. Awesome. We have an equation solved for one of the variables. That's what it told us to do in step 1. That's where we started in A. They gave us, those equations in 1 and in 2 where they were already solved for one of the variables. Now we'll take this and sub it into equation 2. So we know equation 2 looks like 3x plus y equals negative 1. And I want to take my previous stuff and substitute it in. So we're going to take this and push it into y, aren't we? It says y equals x plus 3, so we can replace. I could take 3x, add with it, instead of y, let's put in x plus 3 equals negative 1. Simplify, these two come together, creating 4x plus 3 equals negative 1. And let's keep solving. I didn't leave myself enough room. Hopefully your space management's a little better. I'm going to subtract 3 from both sides. Remember, my goal is to get down to what x is. So I'm getting 4x equals negative 4. And now we know simply divide by 4. And we come out with x equals negative 1. Awesome. We got half our solution, don't we? We need to go on to step 3 now and substitute that value back into one of the original equations. I can go back into equation 1, but remember with equation 1, we ended up solving it for y. So this really is just like a revised equation 1. So I'm going to use the revision. I'm going to go back to y equals x plus 3 and bring this x in as negative 1. So here we go. Y equals, replace x with our known value of negative 1 plus 3. And it looks like y will be 2, doesn't it? Because negative 1 plus 3 equals 2. Y equals 2. And we have ourselves a solution. Negative 1, 2. There's the negative 1. There was the 2. I hope you think this is okay. This is not that hard, is it? It's called the substitution method, and you can understand why it's called substitution method. D is kind of similar. Is D, and then is there a word problem? Well, of course there's a word problem. Let's keep this video a little bit shorter. I know we're at 12 minutes already, so let's go down to example 3 and play this one out. It'll take us through all the steps again. It says a drama club earns $1,040 from a production, like a play. A total of 64 adult tickets and 132 student tickets are sold. Adult tickets cost twice as much as student tickets. Write a system of linear equations that represent the situation. What is the price of each type of ticket? So since we don't know the price, I guess that's going to be our variable. And let's assign a variable to the price of the adult tickets. What do you say? X. Good choice. All right, let's go choose a value or a variable for the student tickets. Are you thinking Y? I know I can read your mind. Let's go with Y. Now, I'm looking at those equations and it says they earned $1,040 by selling 64 adult tickets and 132 tickets. To me, it makes sense that I would go 64 tickets sold and they cost X dollars for those adult tickets. And I also sold 132 of the student price tickets, Y, and that came in as 1,040. Okay, and then we got to write our second equation, which says an adult ticket costs. So an adult ticket costs, that's going to be my equal sign, twice as much as a student ticket. And the student price was Y, so X equals 2Y. And it tells us to use the substitution method. This is going to be kind of nice because I like what I'm seeing here. I'm seeing X equals 2Y, aren't you? And that means that they have given us they've solved one of the equations for the variable. Kind of like when we started this today, we know that x equals 2y. So let's just take that 2y and substitute it into equation 1 for x. So 64. Let's replace x, get it to replaced with 2y, and then continue on our merry little way. 132y equals 1040. Now you'll notice we're just in terms of y, which is a good thing. Having just one variable makes it easier to solve. So we multiplied 64 times 2 and got the 128. Now let's join let's join 128 and 132. And what does that get us for a number? 250, 260, I think. 260 equals 1040. And then we'll use division, won't we, to get down to just a single y. So 1y equals 1040 divided by 260 is 4. So the adult ticket price, no, I'm sorry, the student ticket price is $4. And then that means sub this. This is kind of like step 3. This would have been like step 2. This really was step 1 because they had the variable solved. Let's go into step 3. Step 3 says take our answer and sub it into one of the equations. I'm going to sub it into x equals 2y. So x will be equal to 2. Instead of y, we now know the value of y. It's 4. So x equals 2 times 4, or 8. Adult price is $8. And we all know that the dollar sign belongs in front, not behind. Even though it reads better, $8, dollar sign goes in front. Student price is $4, $4. All right, very good. Hey, you can work on lesson 5-2 assignment. 245 is the page number, and I'll see you tomorrow.